Okay, this tutorial will be about molarity of ions. As a review, remember molarity is equal to moles over liters. So when you're trying to find the molarity of a solution, you need to know how many moles there are of the solute, what is dissolved, in the number of liters of solvent, the solution that it's in, usually water. So let's look at this one. Calculate the concentration of all ions present in the following solutions of strong electrolytes. So we are given 0.0200 moles of sodium phosphate in 10 milliliters of solution. So the first thing is notice that molarity is moles per liter. So we're going to take our milliliters and convert it to liters by dividing by 1,000. Oops. Okay, so that's how many liters we have. So in order to get molarity, we need to know the moles of our target chemical per the liters. Well, we have the liters. So let's take a look at what chemicals we're talking about. All ions present. So let's look at the compound, sodium phosphate. In order to figure out how many ions are present, you need to know the correct compound formula for sodium phosphate. So you must check those charges. Sodium is a +1, phosphate is a -3. So the correct formula for sodium phosphate is Na3PO4. That is for the whole compound. When we take this ionic compound and place it in water, it dissociates, it dissolves, it splits apart into its ions. Well, take a look at this. How many sodium ions are there? You should say 3 because of this subscript right here. And how many phosphate ions? Well, only 1. So when you take this full compound and dissolve it in water, it splits apart into its pieces. So let's think for a moment. If we have 0.020 moles of the whole compound, sodium phosphate, and our goal is to find the molarity of each of the ions, we need to know the moles for sodium. So how many sodium moles there are in solution and how many phosphate moles there are in solution. Where do we get that information? From right here. Our subscripts, our ratio inside the compound, and that will be what is called our mole ratio. So we know that we have this many moles of the whole compound. We also know that in one of these compounds we have how many sodiums? 1, 2, 3. So if we're trying to find out how many moles of sodium we have, we need to take this number and multiply it by the ratio 3 moles of sodium over the 1 mole of the whole compound. That will give us our moles of just sodium because the moles of the whole compound, sodium phosphate, will cancel out. So you take 0.0200 times 3 and you get 0.0600 moles of the sodium ion. Well, we're not done. We want molarity, and molarity is moles over liters. Well, here's our moles of sodium, and we were already given liters at the beginning of the problem. So now it's just division, moles divided by liters. And so our final answer for our molarity of sodium is 6.00 molar of the sodium ion. Okay. So that is only one of the ions. Now we want to figure out the molarity of the phosphate ion. So here we go. Same idea. We know that this is how many moles of sodium phosphate we are given. We also know when sodium phosphate splits apart, when it dissociates in water, we get 1 mole of the phosphate ion for every 1 mole of the whole sodium phosphate compound. So, our moles of phosphate is 0.0200 moles times 1 over 1. It's a 1-to-1 ratio. So we now have our moles of our phosphate ion. And to get molarity, molarity is moles divided by liters, we divide by the liters given. And our answer is 2.00 molarity of the phosphate ion. Okay, so these are the 2 answers. In order to get these answers, what we needed was the mole for each ion over the liters given. To figure out the mole for each ion, you need to write out the whole ionic compound to get the ratio of how many there are of each ion in the whole compound.